Yes, so welcome students, how are you all? So in today's class we are going to discuss about suspension and colloidal solution. Yes, in this chapter हमने इसके पहले की क्लास में all the things that we have discussed were about the pure substance है ना, हमने elements के बारे में पढ़ा, compounds के बारे में पढ़ा, उसके बाद में then we had moved towards the mixture that we have seen what are the homogeneous and heterogeneous mixtures, isn't it? Then in that only we have again gone with a detailed study of what are solutions. Solutions किसको बोलेंगे, what are its properties, ये सारी चीज़ें हमने इसके पहले की क्लासेस में कर ली है. With that also we have seen what is concentration of solution and how we can calculate some numericals on concentration of solution, है ना. So one more part it was remaining, that is what is suspension and colloidal solutions or colloids. So that we will discuss in today's class. आज हम पढ़ेंगे कि suspension क्या होता है और colloids या फिर colloidal solution क्या होता है. Come on, let's start with the class. So first of all, if I talk about suspension, देखो the three things are there: solution, suspension and colloids. What are solutions? That we have already discussed, है ना. Solution किसको बोलेंगे? When the particles are very minute particles, they are easily dissolve, we cannot see the particles. Yeah, so that is what was, it was your solution. It is always forming a homogeneous mixture, है ना. वो homogeneous mixture बनाता है if I am talking about solution. Now what is suspension? First and the main difference is that the suspension is a heterogeneous mixture. क्या है suspension? It is a heterogeneous mixture, students, isn't it? Can you see here? It is a heterogeneous mixture. In that what happens, in which the solute particles, they do not dissolve, but they remain suspended throughout the bulk of the medium. यानी जब आप कोई दो चीज को डिसॉल्व करना चाहोगे, या तो जब सल्यूट रहेगा, जो सल्यूट जिसको हम यू नो ना व्हाट इज सल्यूट आल्सो, isn't it? When we want to dissolve a solute in a solvent, what happens here? The solute particles do not dissolve. वो particles पूरी तरह से dissolve नहीं रहेंगे, आपको वो solvent में उसके particles दिखते रहेंगे. Got it? So dispersion medium जो है उसमें आपको वो dispersed particle दिखते रहेंगे. So that is what we call as an heterogeneous mixture और उसी को हम बोलेंगे suspension. I hope this is clear. Yes. So in a simple way हम बोल सकते हैं कि when the substances that are soluble completely, it is a solution. And when the substances are not soluble or insoluble, then it is a suspension. Got it? Very good examples of suspension are chalk water mixture. आपने देखा होगा chalk powder और water, उसको water में आप डाल दो and what you will find, it is a suspension. That mixture is a suspension. फिर muddy water, है ना, मिट्टी वाला पानी. Sand particles in water, again a very good example of suspension. वो तो आप imagine भी कर सकते हो. When you add some sand particles in water, what can you see? You can see the particles there, है ना. और उसके बाद थोड़ा समय रखने के बाद आप क्या देखोगे कि वो पार्टिकल्स नीचे सेटल हो जा रहे हैं. इट इज नॉट कंप्लीटली डिसॉल्विंग एंड मिक्सिंग इन दैट. या सो दैट्स व्हाई वी विल से सच मिक्सचर्स एज अ सस्पेंशन. आई होप दिस इज क्लियर. या तो इसके बेसिस पे हम क्या बोल सकते हैं कि सस्पेंशन क्या दिमाग में आ रहा है. अब हमको उसकी प्रॉपर्टीज यदि पढ़नी है, सो व्हाट कैन यू से व्हिच विल बी द प्रॉपर्टीज. आई डोंट वांट टू लर्न, मुझे लर्न नहीं करनी है प्रॉपर्टीज, बट मुझे पता रखना है कि प्रॉपर्टीज क्या है. तो कैसे याद रखेंगे? हाउ आई जस्ट कीप इट इन माय माइंड. सबसे पहले आप देख लो, जैसे मैंने कहा कि यू कैन इमेजिन द सैंड पार्टिकल्स इन वाटर और यू कैन इमेजिन अ चॉक वाटर मिक्सचर. सपोज आई टेक a mixture of chalk powder and water. Chalk powder I have taken as a solute and I am adding it to a water, isn't it? So what we will see when we will add this, we will see that a milky solution or the milky suspension, more properly not solution but हम बोलेंगे milky suspension is formed, है ना. मिल्की सस्पेंशन हो जाएगा. अब ये सस्पेंशन में आप देख सकते हो कि जो चॉक पार्टिकल्स हैं, आपको छोटे छोटे पार्टिकल्स दिखेंगे, you can see the particles there. And when you will keep that suspension undisturbed for some time, वो उसको जिसमें भी आप वो सस्पेंशन बना रहे हैं उसको अनडिस्टर्ब रखो थोड़े समय के लिए, तो सो व्हाट यू विल ऑब्जर्व, you will observe that that chalk powder, ये chalk particles, they all have settled down at the bottom, है ना. इफ आई एम मेकिंग इन अ बीकर, तो बीकर के बॉटम में वो सेटल हो गए. सो एक प्रॉपर्टी हम क्या बोल सकते हैं कि दिस सस्पेंशन इज अनस्टेबल. सबसे पहले एक प्रॉपर्टी हम बोल सकते हैं कि इज अनस्टेबल. फिर उसके पार्टिकल्स दिख रहे हैं, isn't it? It is not completely dissolved, so I will say it is a heterogeneous mixture. Am I right? So two properties, no need to learn. That's why I am saying, yes, we can remember in this way. Then when you want to go, if you will take that suspension and you will try to filter. यदि आप इसको फिल्टर करना चाहोगे एक नॉर्मल फिल्टर पेपर से सपोज, सो आप क्या देखोगे, क्या वो फिल्टर हो जाएगा? या yes, when we will try to filter it, we will see that the water, clear water is obtained as a filtrate, है ना. सिर्फ पानी मिलेगा आपको as a filtrate, and the chalk powder, it will be there on a filter paper only. That means separation is possible. Yeah, so this suspension, in a suspension the particles can be separated by, I can say, filtration. That is another property. Yes, we have seen the three one. Then if you will pass some beam of light, यदि आप वो suspension के through एक टॉर्च से या किसी एक बीम ऑफ लाइट को उसमें से पास करोगे, तो आप क्या देखोगे? Will it scatter the particles, or it is visible or not visible? क्या देखोगे? Remember, if a beam of light is passed, how are the particles? The particles are little bit bigger, isn't it? इसीलिए वो dissolve नहीं हो रहे completely. So this it scatters the beam of light. जो beam of light आप पास करोगे वो scatter करेगी, light को scatter करेगी. Yes, वो beaker पे से यदि आप डालोगे, you can see all this thing at your home also. Yes, so that is again one more important property for a suspension. Yeah, so accordingly we can say that ये सारी properties को आप sum up करोगे तो you can see that the suspension is a heterogeneous mixture. Then size of the solute particles in a suspension is what? Is large, quite large, very sorry. Quite large means what I can say? Just a minute, yes. Yeah, quite large, that means how much? It is more than 100 nanometer in diameter. 100 nanometer से भी ज़्यादा रहेगी, यानी हम उसको बोल रहे हैं in that way it is large. Okay, so the particles of a suspension can be seen by the naked eyes. हम उसको खुली आंखों से, अपनी आंखों से भी देख सकते हैं the particles को, क्योंकि उसकी साइज ज़्यादा है, बड़ी है. Got it? Then a suspension is unstable. मैंने बोला unstable क्यों बोलेंगे, क्योंकि जब वो सस्पेंशन को हम अनडिस्टर्ब रखते हैं तो पार्टिकल्स गेट सेटल डाउन. क्लियर? देन द पार्टिकल्स डू नॉट पास थ्रू फिल्टर पेपर. जो सस्पेंशन के पार्टिकल्स है वो फिल्टर पेपर से पास नहीं हो रहा है, इसीलिए तो वो चॉक पाउडर ऊपर ही रह रहा है, सैल्यूट वाला, and the solvent as a water it is coming out, so we can say that they can be separated by filtration. Yeah, and the last property we can remember that they can scatter a beam of light passing through it, and thus they can make the path visible. Got it? So these are some properties of suspension. I hope this is clear. बस आपको इतना याद रखना है for now. What are suspension and what are the different properties of suspension? Yes, तो अब दिमाग में आ गया. If I want to ask you what is the difference between a solution and suspension, can you write the difference on the basis of these properties that we have done? I think you can write. Yes. So the next that we will discuss is the colloids. Yes. So colloidal solution or colloids. What are this? अब ये क्या है? It is also, students, a heterogeneous. But it is very interesting. Listen carefully. ये एक तरह का ऐसा solution होता है. It is heterogeneous. But आप जब उसको देखोगे ना normally, it looks homogeneous. क्यों? क्योंकि इसके जो पार्टिकल साइज रहेगा इन डायमीटर, दे आर इन बिटवीन, यानी वो ट्रू सोल्यूशन जितने छोटे भी नहीं रहेंगे और सस्पेंशन जितने बड़े भी, इट इज इन बिटवीन. The particles are in between. The size of the solute particles, I can say, is intermediate यहाँ पर. Yes, between those in a true solution, yes, and in a suspension. यानी true solution से बड़े और suspension से छोटे. Got it? That's why I can say that it seems to be homogeneous, but actually it is a heterogeneous. Remember this thing. So the particles are uniformly spread throughout the solution. Particles जो रहेंगे वो solution में uniformly spread हो जाएंगे. Yes, a very good example is there. Soap solution आपने देखा है, soap साबुन का जब हम solution बनाते हैं उसको पानी में आप dissolve करो, आप देखोगे कि वो पूरी तरह से dissolve हो जा रहा है. It looks homogeneous, but actually students it is a heterogeneous. Milk. Can you imagine यदि मैं बोल रही हूँ दूध, आप बोलोगी मैम नो, milk is a homogeneous. But no students, milk is not a homogeneous, it is a colloidal solution. Yes, because there it will be an heterogeneous. वहाँ उसके जो particles है, fat globules रहते हैं, proteins रहते हैं, yes, they all are there. The particles are seen, not definitely हम उसको एकदम खुली आंखों से नहीं देख सकते, but yeah, it is a colloidal solution. Then ink, blood, starch solution. Yes, all these are some examples of, I can say, colloids or colloidal solution. Okay, so on this basis उसकी properties हम क्या बोल सकते हैं? We can say the properties is a colloid is again a heterogeneous, just like your suspension. The size of particles cannot be seen with a naked eyes. आप देख सकते हो क्या? नहीं देख सकते हो ना. यदि मैं आपके सामने मिल्क रख रही हूँ या सोप सोल्यूशन रख रही हूँ या इंक रख रही हूँ, you cannot see the particles there with your naked eyes, isn't it? The particles can pass through the filter paper. यदि आप उसको फिल्टर भी करोगे ना तो वो particles पास हो जाएंगे, that means वो फिल्टर हो जाएंगे. So यदि वो निकल रहे हैं फिल्टर पेपर से, so you cannot separate it by filtration. Suspension you can separate it. Yeah, here you cannot separate it. Then colloid is quite stable. Suspension was unstable. Isn't it? Why I am saying stable? जब हम colloid solution को, if you will keep it undisturbed, the particles will not settle down. Got it? So this is again a property of a colloid. Then colloids are big enough to scatter a beam of light. Yes, so particles are like that, they can be filtered, है ना? Filtered यानी हम बोल सकते हैं they can pass through the filter paper, so it cannot be separated क्योंकि they are very small, then you cannot see with your naked eyes also, but the particles can scatter a beam of light. Scattering के लिए जितनी size चाहिए particles की उतनी है उसकी. Yes, they are large enough or big enough to scatter the beam of light passing through it, and it can make the path visible. So this last point is similar to the suspension, isn't it? And first also, that it is a heterogeneous mixture. I hope this is clear. So according to that, you can also differentiate between the colloidal solution as well as the suspension. There are not too much points, but yes, you can say that there are some points on which you can make a differentiation. Just it can pass through the filter paper. Here the particles in the suspension it cannot pass. Then colloids are stable. The suspension is non-stable, unstable there, isn't it? Then we can say the particles cannot be seen here with the naked eyes, but in the suspension it can be seen there. Got it, students? Now there are some different types of colloids also, है ना? Colloids के हम different types भी बोल सकते हैं on the basis of physical state, I can say, of solute and solvent. Solute कौन सा रहेगा और solvent कैसा रहेगा उसकी physical state के basis पे different types of colloids आप देख सकते हो, like sol, then solid sol, aerosol, emulsion. I've given you the name of that, isn't it? Then gel you know, isn't it? Then solid foam as well as foam. ये सारे different types of colloids है. कौन से basis पे? Physical state of solutes and solvent. Yes, that means solute solid है या solvent solid है या फिर solute liquid है, solvent solid है. What is it? On that basis you can classify the colloids in this different types. On that we can say, you can see if I talk about sol, these are the different types of colloids, है ना. यदि मैं बात करती हूँ sol की, so what can you see in a sol? In the sol there are tiny solid particles which are dispersed in a liquid medium. छोटे छोटे सॉलिड पार्टिकल्स लिक्विड मीडियम में डिस्पर्स्ड होंगे. आप एग्जाम्पल सोच लो, व्हाट कुड बी द एग्जाम्पल? वेरी स्मॉल पार्टिकल्स इन अ लिक्विड मीडियम. So soap solution is there, ink is there, mud is there, milk of magnesia. These all are example of sol. Okay. Then if I talk about solid sol. Now what is the difference between this? If I am saying only sol, a solid is dispersed into a liquid medium. In solid sol, both solute and solvent. Again, can I say this is solid in solid here? I think no, this is wrong. There is a mistake here. Chalo, I will make it out. Just a minute. The black color. Yeah, it would be here. There should be not liquid, but here it should be what? It should be solid. Yes, if I am talking about solid, it is solid particles dispersed in solid medium only. Got it? There was a mistake there. Example, you can take it as colored gemstone, then milky glass. Milky glass देखा है या फिर आपने gemstones देखे? We just generally wear on our fingers or its pendant is like that, isn't it? तो वो gemstone आपको कैसे दिखेंगे? वो solid रहेगा. Yes, which is dispersed in a dispersing medium which is also a solid. Got it? That is called as solid sol. फिर emulsion. Yes, next is your emulsion. If I talk about emulsion, emulsion क्या रहेगा? It is a liquid, students. Yes, minute droplets of liquid dispersed in another liquid. You know, liquid and liquid. But yes, which is not miscible with it. This liquid is not miscible with this. Liquid or liquid का रहेगा, but the one is not miscible with the another. Again, milk and some sort of face creams. Yes, इसको हम बोलेंगे emulsion type of colloids. Okay. Then gel. Gel आपने देखा होगा how the gel looks. Yes. So it is a solid, students. Yes, if I am talking about in a liquid. Okay. Solid in a liquid. Jelly, very good example. Gelatin, isn't it? Then cheese. All these are nothing but an example of gel. Then aerosol बोल दिया. Aerosol also, you know what is an aerosol? That means solid or liquid. Yes. Dispersed phase, that means solute. या तो solid हो सकता है या फिर liquid हो सकता है. लेकिन जो dispersion medium रहेगा, solvent रहेगा, it is always a gas. Okay, for example, if I say smoke, यदि मैं बात करती हूँ smoke, तो smoke is an example of solid in gas. Smoke में particles रहेंगे, isn't it? So that is an example of aerosol with solid in gas. If I talk about hairspray, yeah, or if I talk about fog, clouds, this will be an example of aerosol with liquid in gas. I hope this is clear. So this is also one type. यदि मैं बात करती हूँ foam की, just a minute, students. Yeah, if I talk about foam, students, so what can you see in foam? Foam, that means gas. It is dispersed in liquid. Foam देखा है, shaving cream, isn't it a very good example? There is a foam. There is nowadays instead of cream the foams are there. Yes, as for a shaving. So it is a very good example in which the solute is gas. Solute कौन सा रहेगा? Gas और solvent रहता है liquid. Shaving cream, soap bubbles, these all are example of foam. Then there is also solid foam. So again, the solute or the dispersed phase is gas and the dispersing medium is going to be solid there. So that is your foam, rubber, sponge. All this comes under a solid form. So students, you can see the 6 types of colloids on the basis of physical nature of the solid solvent as well as solute. ठीक है. So remember this thing, this is important. इसके ऊपर भी आपको questions पूछे जा सकते हैं and you should remember all these things. आपको पता रहना चाहिए सारी चीजें क्या होती हैं. Got it? So this was about the colloids. This was about the properties of colloids and the types of colloids. Now, a very important effect that is shown by this colloids also. It is called as Tyndall effect. इसको क्या बोलते हैं? Tyndall effect. So what is this Tyndall effect? सबसे पहले ये इफेक्ट को डिस्कवर किया था जॉन टिंडल ने एंड ऑन हिज नेम ओनली द इफेक्ट्स नेम वाज गिवन एज अ टिंडल इफेक्ट. सो व्हाट इज दिस टिंडल इफेक्ट? यू मस्ट ऑल हैव हर्ड, है ना. व्हाट हैपेंस इन ऑल द प्रॉपर्टीज, यदि आपने देखा होगा जब हमने सस्पेंशन पढ़ा, कोलॉइड पढ़ा या सॉल्यूशन पढ़ा, I had always given you one property, whether the light beam of light is scattering or not. Yeah. So that is only what we can say is a Tyndall effect. That is the scattering of beam of light by the colloidal particles. Yes, by the small particles is called as Tyndall effect. Yes, or Tyndall phenomenon also. I hope this is clear. That means when the particles are, students, little big than a true solution से थोड़े बड़े. Yes. तो वैसे पार्टिकल्स क्या करते हैं? लाइट को स्कैटर करते हैं. दिस इज ड्यू टू द स्कैटरिंग फिनोमेना. या दे कैन स्कैटर द बीम ऑफ लाइट एंड व्हेन दे स्कैटर द बीम ऑफ लाइट तो क्या, और ये लाइट पास होने से इफ इट इज गोइंग लाइक दिस, इट इज गोइंग टू स्कैटर लाइक दैट. सो दिस इफेक्ट व्हाट इज कॉल्ड एज अ टिंडल इफेक्ट. क्या, तो जब भी आप कोलॉइड सॉल्यूशन के थ्रू आप लाइट को पास करोगे, ठीक है, तो वो जो पार्टिकल्स रहेंगे उसमें वो क्या करते हैं? वो लाइट को स्कैटर करेंगे एंड डू नॉट अलाउ द इट टू पास थ्रू इट. ठीक है. सो दैट इज कॉल्ड एज व्हाट? टिंडल इफेक्ट. एंड ड्यू टू द स्कैटरिंग, क्योंकि लाइट स्कैटर हो रही है, सो द पाथ ऑफ लाइट बिकम्स विजिबल. यस, पाथ ऑफ लाइट बिकम्स व्हाट? विजिबल. आपको दिखेगी वो लाइट. गॉट इट? जबकि ट्रू सॉल्यूशन में क्या होता है? द पार्टिकल्स आर वेरी स्मॉल, सो दे कैन नॉट स्कैटर द लाइट. दैट्स व्हाई ट्रू सॉल्यूशन, द बीम ऑफ लाइट, इट डू नॉट स्कैटर और इट डू नॉट शो द टिंडल इफेक्ट. गॉट इट स्टूडेंट्स? ओके, यू कैन सी हियर. आप यहाँ पे देख सकते हो. यदि मैं एक ट्रू सॉल्यूशन ले रही हूँ, सपोज फॉर एग्जाम्पल आई हैव टेकन अ शुगर सॉल्यूशन. वेरी सॉरी. If I am taking a sugar solution, so what is there? To this solution, if I pass a beam of light, यदि मैं ये beam of light torch के through इससे pass कर रही हूँ solution पे, तो what you will see, यहाँ पर आपको कोई भी light नहीं दिखेगी. The light comes in this way. There in this, the light is not visible. Why? क्योंकि जो particles है इसके, they are very small. They are not going to scatter the beam of light. Got it? So this happens in true solution. I hope this is clear. Yes, and again students, if I you can see here, the next is your colloidal solution, है ना. यदि colloid solution है या फिर colloidal solution है, if I pass a beam of light through that, what can you see? आप क्या देख सकते हो वहाँ पे? You can see that this light is visible through this beaker. यहाँ से आपको ये लाइट पूरी ऐसी दिखेगी. Yes, continuous you can see the light through this solution also. Why? Because these particles, they are little bit bigger than the true solution. और ये particles क्या कर रहे हैं? वो लाइट को scatter कर रहे हैं. Yes, and that's why what are they making? They are making the path of light visible. लाइट का path को visible कर रहे हैं. क्यों? इसीलिए हमको वो लाइट दिख रही है. Yeah, so this is what we called as a Tyndall phenomena or Tyndall effect. I hope this is clear, which is shown by the colloidal colloidal solution. Yeah, there are some example of Tyndall effect. आप देख सकते हो. First of all, as you know, beam of light entering dark room through the hole. आप पूरा अंधेरा कर लो घर में. Yes. और या फिर खिड़की में से थोड़ा सा उसको जगह कर दो, खिड़की थोड़ी सी खोल दो, बिल्कुल थोड़ी सी. Isn't it? Or if there is some hole in the room, what you see? The small hole is there. If from there also, or through a small opening from a window also it is open, the light enters from the small place and it scatters in the room, है ना, रूम में फैल जाती है. So why this is happening? This is due to the scattering only. Isn't it? This is due to the scattering of particles of what? कौन से particles रहेंगे वहाँ पर? Dust particles रहेंगे, smoke, एयर में कुछ स्मोक रहता है उसके कारण भी हो सकता है. So all that particles, dust particles, smoke particles, yes, they will scatter that light. Yes, and light, the room will enter throughout the room and it will be, वो रूम में रोशनी आ जाएगी. Yes, जैसे आप देख सकते हो, ये एक और चीज है, like sunlight when passes through a canopy, you can say this is a canopy, isn't it? ये जो canopy है, that means the big trees are there, isn't it? They are forming the canopy and through that canopy यदि वहां से आपकी sunlight pass होती है, so this light is spreading, isn't it? It is scattering. Can you see this? This is what is called as a Tyndall effect. I hope this is clear. है ना. रूम में क्या हो रहा है? रूम में यदि मैं बात करूँ तो डस्ट पार्टिकल्स विल बी देयर विच आर रिस्पॉन्सिबल to make the room when the light enters and it scatters the light. If I talk about the canopy, in the environment we know in the air there will be dust particle, there are different gases, there are different smokes, बहुत सारे pollution particles भी रहेंगे, am I right? So there are so many different particles which are responsible for this Tyndall effect when a sunlight passes through a canopy. Okay. Then beam of light pass through a milk solution. आप milk solution के through भी आप beam of light pass करके देख सकते हो. You will see that the path of light is visible. Scatter हो रहा है, isn't it? कौन कौन से particles रहेंगे milk में? As I told you, the fat globules are there, isn't it? Proteins are there. Yeah. So these are responsible for scattering of light in the through the milk solution. That's why milk is a colloid. Got it? Then if a torch is switched in a foggy environment, बहुत ज़्यादा fog है, in that foggy environment, if you will switch on the torch, or for example here, like you can see, it is a foggy night there, the road or complete foggy thing is there, and some signal light is on, isn't it? So how can you see this? This light when the signal is on, this is scattered. ये light देखो scattered हो रही है. Am I right? Yeah. So this is again why this is again because in the fog क्या होता है? There are water droplets, isn't it? Some water droplets are there. If I am talking of fog, तो ये जो water droplets है, they are responsible for scattering of this light in a foggy environment. Yeah. So this is some examples of Tyndall effect. You can take many more examples. बहुत सारे examples आप देख सकते हो. But with that you should remember who is responsible for scattering that light. Yes, different examples, it will give you different things. Definitely, I think now this thing is very much clear. What is Tyndall effect? ये भी आपको अच्छे से समझ में आया. Now the last thing that we will discuss is the comparison. हमने अब तक सोल्यूशन पढ़ा, सस्पेंशन पढ़ा और कोलॉइड्स पढ़ा. हम एक बार उसका कंपैरिजन पढ़ लेंगे सो दैट आपको ये तीनों चीजें इट विल बी मच क्लियर रिलेटेड टू द प्रॉपर्टीज, इजंट इट? ये पहला है, इट इज अ ट्रू सोल्यूशन, देन इट इज सस्पेंशन एंड कोलॉइड. इफ आई टॉक अबाउट द पार्टिकल साइज, मैंने आपको बताया था ट्रू सोल्यूशन का पार्टिकल्स बहुत छोटे रहते हैं. दे आर लेस देन 1 नैनोमीटर इन डायमीटर्स. Particle size. If I talk about suspension, they are greater than 1 nanometer, or you can say that they are till the 100 nanometers also, isn't it? वहाँ से ऊपर भी रहेंगे. And colloids, the particles are between 1 nanometer to 100 nanometer. I hope this is clear. Then the nature of your true solution, it is homogeneous, and these other two, suspension or colloids कैसे है, they both are heterogeneous. विजिबिलिटी ऑफ पार्टिकल्स, कौन से सोल्यूशन में, कौन से मिक्सचर में पार्टिकल विजिबल होते हैं. सो ट्रू सोल्यूशन में द पार्टिकल्स आर नॉट विजिबल बिकॉज दे आर वेरी स्मॉल, सो इट इज इनविजिबल. In suspension, they are bigger particles, so they are visible. Colloids, they are also visible, not in a naked eye से visible नहीं होंगे, okay, but when you will see under the ultra microscope, they are visible. Got it? If I talk about scattering of light, we know the true solution do not scatter light. Colloid, it will scatter the light. Suspensions, they can also, but generally we can say that do not. But yes, I can write here that yes, they can. You can see that the light can be scattered through the suspension also. Okay, so you can, but the colloidal particles, they generally scatter the light. Now filterability. If I am talking about filterability, what can we say about the filterability, students? कौन से particles they are going to be filtered and which is not in the solution. If I am saying it is very smaller, so it can easily pass through the filter paper and the animal membrane. Yes, it can easily pass through the filter paper and animal membrane. If I am talking about the suspension, I told you they are the big particles रहते हैं, isn't it? So it cannot pass through the filter paper and the animal membrane. If I talk about the colloids, it can pass through the filter paper but not through the animal membrane. Remember this thing. Filter paper से pass हो जाएंगे but animal membrane से नहीं होंगे. Now settling of particles, ये settle नहीं होते, do not settle. Suspension, definitely they settle. Yes, colloids also do not settle, but they can settle only by centrifugation. आप centrifugation यदि करोगे with a high speed, if you will rotate it, yes, centrifugation is a technique there to separate, isn't it? यदि आप उसको centrifugation से settle करना चाहोगे, तो it can be settled there, yeah. But the true solution particles, they will not settle at all. Suspension, here you can write, students, I think there we can, I will correct this thing again. We can write here that the particles where I have written the scattering of light, suspension scatters the beam of light. Na? So scatters the light, I can write here. Yes, scatters the light. Yeah. So now these are the comparative points between the true solution, suspension and colloidal solution. I hope this will be clear. इससे आपके तीनों चीज ये चार्ट से, ये टेबल से आपका ये तीनों चीज क्लियर हो गए. आपको सिर्फ उसके एग्जाम्पल्स याद रखने हैं. And you can also learn, keep in mind the Tyndall effect. That is again a very simple again, isn't it? Chalo. So we will stop. Now from this chapter, the physical and chemical changes are remaining and some separation techniques are remaining. So we will discuss that in the next class. Yes, till then all of you, I think, bye, take care. Thank you for attending the class, and keep learning till we meet in the next class. All the best for your studies, and if you want to join the app, you can download the app through this link which I have given there. And in the app you will also get the detailed notes and explanation materials with that. Okay, till then all of you, bye bye, take care. And yes, if you like the videos, please share, subscribe the channel as well as like it. Yeah, bye students.